Hello, everybody, again after our lunch break. I hope that you are ready for last two presentations on our track today. And now with me is Thomas Schuetz. Hello, Thomas. Nice to meet you.
Hello, thanks for having me here.
Yeah, and Thomas will tell us something about unifying infrastructure application delivery. So maybe let's start with kind of question that based on your current experience and current, let's say, trip or adventure which you had with unifying infrastructure and application delivery. So the infrastructure and software deployment should or should not be unified.
I think it should be unified. I've been working in systems administration and cloud engineering in the last 2 decades, and I often experienced problems, especially with this topic, and therefore I think there might be some unification.
Okay, great to hear. So I can't wait your presentation. So the floor is yours, and keeping fingers crossed for you and for your presentation. Have
Okay,
fun.
thank you. Okay, so hello everyone. My name is Thomas Schuetz. I'm a principal and maintainer of Captain. And today I want to share some thoughts and ideas about unifying application and infrastructure deployment with you. And I will show you some points how this could work with an open source project called Captain. Okay, so at first, why am I here? So a few months ago, I wrote a blog post regarding how to combine and automate infrastructure and application deployment in a microservice environment. And this was kind of based on things I experienced by myself, and I tried. It cannot be that this is so hard. So I thought a bit about it and thought it would be nice to write this down a bit. And after some time, I got very good feedback regarding this and thought it would be nice to speak about this. And yes, that's why I'm here today. Okay, so what will we talk about today? At first, we will talk about the problem. So why is this a problem? Why has this to be a problem? And based on specific use cases. Furthermore, we will talk about application and infrastructure boundaries. So which kind of infrastructure should belong where? At third, we will talk about putting observability into the driver's seat and what this means. I will tell to you afterwards. Then we will talk about how Captain can help you doing this. And in the end, we will wrap this up and drive this home, and you will have enough place for questions. So let's start. As I said before, I'm in infrastructure engineering for about 20 years, and I saw a lot of problems when I administered infrastructure and deployed applications. So one of the problems was that in the beginning, we had a lot to do with Snowflake servers. So there were many servers administered by hand. There was no administration. And when you tried to promote something from one, let's say, server to the next higher level server, such as from a development to a staging environment, it was also hard. It was always hard to get the changes to the servers. Furthermore, we also had a lot of problems with dev and prod uniqueness. So when we developed something in a development system and we had to put this in production, sometimes we couldn't remember what we did on dev because there were some important changes, and this got also a really big problem. Furthermore, and this is almost the same as the other two things. When we tried to get some configuration management in there, there were also some manual changes on pre-dev environments, which were not reflected on the higher stages. So at some point in time, we had automation, but sometimes we also had to make changes by hand, and they were not reflected in the configuration management. And last but not least, our infrastructure changed often, and the application changed often. And the teams which were in charge for the applications and infrastructures didn't know about each other, and this caused a lot of problems. So today we're living in a cloud native world, and we should think that this might not be a problem, but there are also some ones. So at first, it could happen that there are manual infrastructure changes. So for instance, when we administer our Kubernetes cluster, sometimes we might change something on the infrastructure, also manually, even if it's not optimal. And other things which might happen are that we're getting to higher stages, so from a dev to a staging environment, and we could find out that some things are missing. So for instance, when we were working on a dev environment, we might have a specific ingress class, we might have a storage class, and we might have our DNS entries. But these are no more available on the higher stage. Therefore, this could also lead to problems, especially when updating applications. Other things, there could be no new applications on our infrastructure, which could cause resource limitations. Our problems could be caused by resource limitations. So think of you deploy a new application which needs 4 gigabytes of RAM of memory and 2, 3, 4 CPUs, and the Kubernetes cluster is not large enough and autoscaling is disabled. So yes, this could also cause lots of problems. And last but not least, our platform could get upgraded and resource types could not be available anymore or not be available in further consequence. So as you see by these examples, our problems didn't change. So we already have we already have the differentiation between infrastructure and application deployment. And yes, this is what I'll talk about in the next few minutes. Okay, so yes, today when we talk about infrastructure deployment, we will mainly talk about infrastructure as code. We have our tools like Terraform, Crossplane, Pulumi, and whatever. And after all of these tools have done their work, so deployed the infrastructure, we know some things. So at first, we know that our configuration is applied. Secondly, we know that sometimes our health checks are okay, depending on the application you're using to deploy this. But there are also things we don't know. So at first, after applying an infrastructure change, we don't know if our applications are running. So most of the times we are updating a Kubernetes cluster and so on, but we will not know if our customer is able to run our application. Furthermore, we didn't check if there was any risk to apply this configuration. So we did not have a look on how many problems did we have in the past, and if this was safe for our customers to apply this configuration. And last but not least, how do we get this configuration to the next stage? Okay, this was the infrastructure part of the story. Then we have the application part of the story, and today we are mainly talking about GitOps and shiny tools like Flux and Argo. So what we know after our GitOps tool stepped in and after we deployed our application is that the technical state of our application is met. So for instance, we know in a deployment where we specified that 3 replicas should be there and a service, they should use a specific service account and so on, that especially this technically desired state is met. The second thing we know is that the health checks of the applications are okay. But what we also didn't know before we did some update, we didn't know that the application was ready for this deployment, or the infrastructure was ready for this deployment, sorry. We also didn't know how risky it was to deploy this application. So it might be that our application, that our customer is already very angry because we had a lot of failures and we didn't check for that. And also, last but not least, we know that our technically desired state is met, but we don't know if our application is really running. So For instance, as I said before, we know that everything we declared in our configuration is done, but we don't know if a customer clicks on a button in his web browser, if he gets a response in 1 second or if he gets it in 20 seconds. And I would say if he gets a response in 20 seconds, his application is not really okay. Okay, so I think we have problems enough, and I think we should solve them somehow. So let's talk a bit about application and infrastructure boundaries, and this is an approach. So at first, we have our infrastructure part. And when we talk about infrastructure, we are also always talking about cloud infrastructure, things like VPCs, firewalls, instances, and whatever belongs to such things. And in a Kubernetes world, we are always talking about storage, networking, policies, templates, custom resource definitions, and also the operators which are maintaining everything, infrastructure components, and so on. So these are the things in a modern world, I would say, which belong to the infrastructure itself. And on the other hand, we have the application part, and you see that on one platform, there is not only running one application. So there can be a lot of applications. And these applications are using the infrastructure. So when you deploy your shiny web application, you might use the storage which is provided by the Kubernetes cluster. You might also use their policies, and you might also use their templates or custom resource definitions which are defined by operators. And what we need to be sure that everything we need for the application is here is we should have a clear contract between the application and the platform. And this could be there in various ways. So you could define this as config maps, as custom resource definitions in configuration management, or whatever you'd like to use. And what you should define there is what are apps allowed to use. So, for instance, you don't want applications to talk to some servers on the internet, but you also might want to have templates which you can use with your applications. Okay, and when we deploy our application, we want to deploy services by themselves, and they might use such things as databases, DNS entries or certificates, and they should also have the monitoring configuration in there, because this might be a prerequisite for evaluations we are doing afterwards. And when we think about this, we will deploy the infrastructure in a separate way. Sometimes it's not possible in another way, depending on the tooling. But we also always deploy our whole application. And during the application deployment, we might also want to update our database, our DNS entries, and our certificates. And using this bundled deployment, so when your application is depending on a database version, and you update the database with your application, you can ensure that you're always running on the right version. Okay, and another thing I told you before, is that we want to put observability on the driver's seat of our deployment. So if we think of this as our steering wheel, we might always want to meet certain service level objectives, service level indicators to make our customers happy. And therefore, we can ask ourselves some questions. So at first, is my error budget already consumed? So before I want to deploy something, I want to ensure that my customer isn't angry, and I can, it might not be a big problem if I'm not available for, let's say, 1 minute. And the answer for that is, no, error budget is not consumed, and go ahead and deploy. A second question we could ask ourselves is, my infrastructure deployment is done. How are my services? So as we saw before, we could deploy an infrastructure, but we will not know if our application is running. And our observability solution could tell ourselves, one service is not okay anymore. So disable the problematic feature of this service. So the other developers might have the possibility to get this working again. And last but not least, after we deployed everything, we could always ask our observability solution if my service is still okay. And my observability solution could say, no, roll back to the last known good version and notify the developers about this. So as you saw here, there are a lot of questions we might have when we are deploying and operating applications, which can be answered by our observability solution and can make the quality of our services better. Okay, and now I talked a bit about Captain before, and some of you might ask, what is Captain and how can it help me? So at first, Captain is an orchestrator for your continuous delivery workflow. So you can use it to orchestrate your deployment tools and get across multiple stages. So we are always running in a loop from deploying, testing, validating, and releasing. And what this means, you will hear in further consequence. The second thing we always saw is we can deal with your day one and day two operations, such as making canary releases, doing remediation actions, and also this runs in a loop during your whole life cycle. And SLOs are put in the center of the whole deployment process. So what Captain itself is not a deployment tool. Captain is a deployment orchestrator, and it is very good in making data-driven decisions based on SLOs. And you can integrate many observability platforms, just like Dynatrace, Prometheus, and Datadog. Okay, and what Captain also can is it can connect any existing delivery test, notification, and so on tool to help you achieving these goals. So for instance, you could use Argo CD for deploying, you could use Flux for deploying, you could use Litmus Chaos, Jamita, Locust, and whatever for testing. And afterwards, connect this with your observability provider and your data to get your deployment done. Good. And to get back to our initial problem. So when we want to deploy our infrastructure and applications in a data-driven way, we have our infrastructure part on the upper part of the slide and our application part on the lower part of the slide. And in the mid, we always are checking against our SLOs. So at first, we need monitoring to get data we need for everything. Secondly, before we do some deployments on our infrastructure, we should check the error budget of our infrastructure to ensure that we know what we are doing and that we know that that our customer will stay happy. Furthermore, after we check the error budgets of our infrastructure, we should also check the error budgets of our applications, because it might be that our application is not really the problem, but we could cause problems on the applications themselves. And this would be in the perfect world. So if we do the first check and everything is okay, we could automatically and without any problems step further to the next step. If this is not okay, so if the first error budget is not met, it might also happen that we want to approve that we want to go further, nevertheless, because it might be that we want to fix a problem. Okay, so after some time, we also check that the error budget of our applications are okay, And now we could update and install our infrastructure, or install our infrastructure. Also, if there are problems with the error budgets of the applications, we could manually approve this. And for updating and installing infrastructure, we could use tools like Terraform, Crossplane, and Pulumi, as we talked before. After we installed everything, we could also always test, evaluate our infrastructure. We might have tests which cause which put some load on the applications, and our observability solution might give us information about how this behaves or how the infrastructure behaves. And after that, we could have some kind of infrastructure version held in our system to be consumed by the applications. And yes, we could also get further to this if there were any problems. And in the first step, this would be the whole deployment process of the infrastructure. After that, we could go further to our applications, and also there, our baseline our base for everything is monitoring. So in a GitOps world, we might have our Argo CD Flux installation and whatever, which continuously watches a Git repository and might trigger the deployment of an application if something is changed. And therefore, the first thing we could do in this step would be that we check if the infrastructure version we need is there. If it's not there, we could wait until it's the case. If it will not appear, then we can always fail. After that, we should also check the error budgets of our service. So as we said before, we don't want our customers to be angry. After that, we did all of our pre-deployment checks. So we know that our error budgets are met. We know that the infrastructure version is especially the thing we want it to be. So we could start deploying our preview environment. And what you see here is mainly about blue-green deployments. So yes, in fact, you can only update the infrastructure once, but you can update the application in a blue-green fashion. And for deploying the preview service, yes, you can also, if you have a problem with the error budgets there, you can also approve this. And for the deployment of the preview service and the infrastructure, you could also use Crossplane, Terraform, Pulumi. And when you take a look on the two tool sets, they could also be stacked. So, for instance, you could set up your Crossplane your Kubernetes cluster using Crossplane, and you could use this server to install your database on this. And in further consequence, you can tell Argo or Flux to update this application. And afterwards, you will also do some testing, evaluation, try to find out if the application works as you want it to work, and could promote. So you could switch the traffic to the new of the live version to the new version. Even if this doesn't work, you can always do an approval. And this can also be done by using tools like Argo rollouts, or in this case, Flagger. Okay, and last but not least, also after we have promoted and everything is okay, we also want to test and evaluate the state of our application. So of the thing which is live now. And after this has happened, we can promote to the next stage. So let's say we could switch from a staging environment to a production environment. This could also be overridden as every time, and this might happen by pushing something to the Git repository where everything based. Okay, you might think at the moment everything clear. We made some infrastructure deployment, we made some application deployment, but how does this fit together? And in this case, we could enhance our infrastructure deployment by triggering service evaluations of the services themselves. And when we think of this, after every infrastructure deployment, we could trigger every service evaluation of every single service which is here on the platform where it's deployed. We will always test and evaluate the applications. If everything is okay, everything's fine for the infrastructure. But if not, we could always trigger remediation actions. So, for instance, we find out that service C is not behaving as it should, and our observability solution might find out that this is a problem in one specific function. And one of our remediation actions could be that we disable this function by a feature flag. And notify our developers afterwards. Furthermore, and after everything is deployed and we thought that everything is okay, and if we find out 2 or 3 hours later that our as it should, our monitoring could tell our platform to remediate. So, for instance, there could be the same case, but only caused by the monitoring solution, and afterwards this and developer gets notified or an action is taken. Okay, and I think I've talked a lot until now, and I just wanted to show you how such a typical deployment of a service, so not the combined, this would take too long in this case, would be looking with Argo CD and Captain. Okay, so what we see here is we have a Captain instance and we have a lot of sequences here. Captain is so Captain has some abstraction layers like projects. It knows services and it knows stages. In my case, I have one project which is called Argo Demo. I have one service which is called the Potato Head, and I have 3 stages and one of them is called Dev. Captain workflows or pipelines are mainly called sequences, and what you see here is that my delivery sequences of the last 20, 30 times were successful. So now, how does such a deployment look like when we use Argo CD? At first, everything is based on a Git repository. We might have our application definition in a config file, which is called potato dev in my case. And let's say I simply want to update this version to this application to a new version. So let's say I have the version 0.20. Therefore, I commit my changes. And after some time, in my Argo installation, I might see that everything gets out of sync. And in this case, we also see that a Captain sequence is triggered. And the first things we could do in such a sequence is we could check our error budget, and we could do an approval if everything is to say, yes, I want to deliver this application now. And in my case, I will simply approve this. And what we should see in a few seconds in Argo CD is that everything gets syncing and progressing. Hours later. Yes, so now we are seeing that the application got synced. We see that our target revision is 0.20 now, and we see that everything is progressing. So Argo CD is trying to get the application to the state we defined here, and now everything is healthy. So Argo CD notified Captain about the finished deployment. We also see that we delivered our infrastructure. There's not a lot of infrastructure, so this was really fast. And after all of this, we could have post-deployment steps which test our applications. So for instance, and I will step back to the last demonstration here. In my case, I did some tests using K6, so a load testing tool. After that, I found out that everything is okay. And now there are other things where Captain comes in. And we could do some evaluations based on the observability data we collected throughout the whole process. And such an evaluation could look like this. For instance, you see the total score of the things we had here. We see the error rate of the application, and what we tried to evaluate here was that we don't want our application to have any errors before we deploy it, before we proceed. And we could also check the response time in 90% of the cases and in 95% of the cases. And this is specified in Captain as service level indicators. And so every line you see here is a service level indicator. And from that, we are calculating an SLO. And we see the values here on the bottom. And what we also see is that Captain calculates a score. And this score can be used in various ways. So, for instance, you could say if my application has a score of above 90, then everything is okay for me and I deploy automatically to the next stage. But you could also say, if my application has a score between 80 and 90, my application might not run perfectly at the moment, but it's enough for my feature to get out, and therefore you could approve this manually. So what you see here is that Captain is very good in taking decisions. After some time, my new application deployment should also be finished. I think this takes 2 or 3 minutes to evaluate. I think we won't wait for this anymore. Okay, so let's get back to the presentation. So what you saw here in this short demo and the presentation before, you see that updating our infrastructure can lead to application problems. So we should take care about this at some point. It would make sense to bind some infrastructure components we need to run our applications, just like databases, just like DNS entries, just like certificates, as far as possible to our microservice to deploy them at the moment at the perfect moment. And for me, the perfect moment is the moment when the application gets deployed. So not 2 weeks earlier and not 2 weeks later. And we should validate our deployments in a customer-centric way. So using service level objectives and error budgets. And another thing which we should always do if our operators and controllers and so on do not do this by themselves, we should continuously watch and remediate our infrastructure to always fit our SLOs and error budgets. Okay, this was it from my side. So my name is Thomas Schuetz. I'm principal engineer for Dynatrace, maintainer for Captain. You can always reach me on the Captain Slack, on Twitter, and wherever. And yes, thanks for having me here. Thanks for your attendance. And yes, now I'm open for questions.
Yeah, thank you, Thomas, for your presentation. Really interesting case, really interesting topics. I can't see any questions on Q&A chat, but I have some questions. So let me start maybe with my questions, and then I would like to also encourage you to ask our great speaker. Okay, so you mentioned few budgets, error budgets, infrastructure, service, and so on. So my question is how that budget should be defined and how to calculate them, how to define them, who should do that, and who should be responsible for maintaining them, because I'm assuming that from time to time that budgets can be changed. Yeah.
So that's a great question, which we also discussed a lot about last week at KubeCon. And in my opinion, the budgets should be defined by people who are close to customers. So, for instance, I as a developer do not really know, so I can make guesses, but I don't really know what our customer is accepting or not. So in this case, the product manager, or yes, mainly the product manager, should define which budgets and service level objectives are okay. and we as engineers should develop against this.
Mhm.
So we should, for instance, if I have a search engine and my customer accepts that it takes about 1 or 2 seconds for a result to appear,
Mhm.
then it's totally okay. But the developers should be aware of that, and they should develop against this goal.
Mhm. Yeah, 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 absolutely. It was really interesting for me that you engaged that kind of metrics, which, let's say, are quite natural from the from the operations maybe perspective. That hey, we are monitoring if our application is responding, if it's responding with, let's say, not too much time, yeah, and so on and so
Mm.
forth. But I have never thought, to be honest, about engaging that in our, let's say, deployment process.
Yes, but I think this feels this yes, it might feel natural, and I think it also is natural that we try to develop against the goals which our customer needs and not against our own goals.
Yeah, yeah. Usually I have a feeling that okay, we are checking during the deployment if it's, let's say, tests are green or it's
Mm.
built properly, but and then we are deploying the application in production, and then from time to time something is exploding because oh god, we did a mistake in query to the database, and it takes
Mm.
hours to get the response. So yeah, it's also good to have that metrics during the deployment to check if everything will work properly as it's currently. Yeah. So.
Mm. So I saw this very much, especially in earlier times of my career, that tests of applications and so on were done manually and not always reproducible and not always against the customer needs.
Mhm.
And this often caused problems after staging processes and getting things in production.
Yeah. Yeah. Exactly.
With this approach, by adding a lot of load to the application, trying to find out how the application behaves and so on, I think you can avoid this.
And maybe one additional question from my side: is it good from your perspective to add kind of, let's say, performance tests also to that pipeline? For example, we are trying to deploy the new version of application, and we are thinking if, for example, it's kind of a commerce application, and if the traffic on Black Friday will be managed by that application. So from your perspective, it's also good, for example, to add that kind of metric to your pipeline.
I think as long as it makes sense, it's totally okay. So you shouldn't add tests or metrics which will bring the systems to explode with a load you will never have. But what we one thing we always try and always propagate is that it would be nice to include chaos and load tests at the same time.
Mhm.
So, for instance, you should ensure that that one part of your application can break,
Mhm.
but nevertheless, the SLOs should not be violated in any way.
Mhm. Yeah, yeah, absolutely. I agree. Yeah, it's always good to check if part of application can be broken, and in the same time, during the, let's say, casual traffic, everything will still work somehow at least. Yeah.
Hmm?
Yeah. Okay. Thanks, Thomas, for your presentation and answering my questions. I can't see any additional questions on Q&A, so I think that Thomas is open for your questions on other, let's say, social channels. So
Mhm.
thank you for your presentation. Thank you for your time, and I would like to also invite you and our participants to the last presentation on our track within, as I can see, 10 minutes. So thank you again, and see you there, and see you somehow, someone and somewhere.
Okay, thanks for having me here. Bye.
Bye.